Today we're going to talk about surface area and volume of a sphere. So a sphere is pretty much your three-dimensional equivalent for a circle. So circles in 2 dimensions are all the points that are the same distance away from the center. If you take the 3 dimensions and you let your points go all over, as long as they're the same distance away from that center point, you've created your sphere. And that distance that's the same to all these different points, that is what we would call the radius. So the radius of our sphere. Now, if you take that sphere and you slice it in half and you get that cross section that we've talked about in the past, um, if you do it so that you have that cross section, now it's going to be a circle. If you cut it so that the circle you've created has the same radius as your sphere, so typically that's slicing straight through the middle, has to include the center point, then what you've done is you've created something called a great circle. So if I were to slice this, up top here, that's no longer a great circle. That's not even really a circle. So we're going to try this again. If I did my cross section here, it is still a circle. The cross section is a circle, but it's no longer a great circle. So that great circle has to include the center. It has to have the same radius, but it can be crossed. It can be cut a couple different ways. You can cut it that way, this way. Oops. We're going to pretend that was a circle. Let's try it again. There you go. Those are all these great circles. So that idea is going to come into play. So your radius of your sphere is the radius of your great circle. Looking at the surface area and volume formulas, surface area formula looks pretty similar to the area of a circle formula. Area of a circle is pi r squared. Surface area of a sphere is 4 pi r squared. So the surface area of a sphere is 4 of those great circles. 4 of those circles that you would get if you were to do a cross section including your center. So the way I think about this, the way I sort of remember this is if I think about a baseball. So if you think about how a baseball is made, you've got these two pieces of leather that are stitched together. And if I were to unstitch them, I get these two shapes here. It's the same shape, just two pieces of it. And they aren't quite circles, but they're close. You could sort of see if you were to take this extra space in the middle, this extra leather in the middle, and you were to move it up, you could, and make that into an actual circle. If you did that, I have one circle here, and then I have another circle down here. So together, that one piece of leather makes two circles. And it's the same thing. I've got one circle here, one circle here. So if I think about that baseball, unraveling that baseball, the two pieces each have two circles. So together, it takes 4 of those great circles to cover the outside of my baseball, to cover the outside of my sphere. Okay. The other way to think about it is, you think about that orange. If you think about the peel on an orange, that's your surface area. If you were to cut that orange in half, here's that great circle we've been talking about. It would take 4 of those to cover the outside of a full orange, the peel of that orange. Okay, so surface area for a sphere is 4 pi r squared. Volume for a sphere is a slightly more complicated formula, not too much more complicated, but slightly more complicated. The reason why the volume of a sphere is what it is has to do with calculus, and so we're not going to get into that, but it is this formula. This is 4/3 pi r cubed. Now the big difference here is if I look at surface area, I'm squaring my radius. If I look at volume, I am cubing it, cubing the volume of my radius, or just cubing the radius to get the volume of my sphere. And so that's a big difference there. It's a really easy place to make a mistake. So you just have to be careful. And so one way to think about it is units for area. Units for surface area is inches squared, meters squared, feet squared. So my radius is going to be squared. Whereas volume for volumes units are inches cubed, meters cubed, feet cubed. So I need to cube my radius. Now I do want to quickly talk about this half orange. So that half orange, if that orange was completely spherical, would be what we would call a semi-sphere. So a semi-sphere, that's just half of a sphere. You may see these. You won't see many of them if you do, but if you do, you might see them, and I want to show you what the formulas are for them. We're going to talk about surface area in just a minute. It's a little bit more complicated, but volume of a half sphere is literally just half the volume of a full sphere. So this is 1/2 4/3 pi r cubed, and we can actually clean up that fraction a little bit, and it becomes 2/3 pi r cubed. So that's the volume for a semi-sphere, volume for a half sphere. Surface area is a little bit more complicated because if I'm thinking about an orange, like a full orange, my surface area is that orange peel. But as soon as we slice that orange in half, I have half the peel, so that makes sense. But now I've exposed this whole piece right here that was originally hidden. Before I cut that orange in half, that piece is originally covered up and I can't see it, so it's not a part of my surface area. But as soon as I slice my orange, I've now exposed this additional circle. So when I do the surface area for a semisphere, I need half the original surface area. I need half that peel. So I need 2 of my great circles. But now I have this exposed side, which is another circle. So altogether, my surface area is 3 pi r cubed, 3 of those great circles. So again, you probably won't see many of these. Most likely you'll see them either as a composite figure, or you might see one on IXL, but I just want you to have those formulas in case you do need them. We're going to do 2 examples. In the 2 examples, because volume is cubing, we're going to have to do some cubing and some uncubing on our calculator. I'm going to try and make it into this video, but it doesn't always like to go to the camera when I'm doing the videos on my iPad, so it might be a separate video. I'm going to try and make it in this one though. We're going to see if it'll let me. In example number 1, we have to do 2 things. We have to find the surface area, and we have to find the volume of our sphere. Now, we don't have a picture. We could try and draw a picture. Spheres are not typically the easiest thing to draw. What you would do is you would draw kind of a lot of ellipses, a lot of ovals. We're going to try and make this. That's not terrible. It's not the best. But we're going to try our best. We're going to see. That's not so bad. But it's not the easiest. You do not need to draw a picture of a sphere. But I have that sphere there, and we know the radius of that sphere is 15. I'm actually going to do that in a different color so it pops a little bit more. There's my radius. There's 15. I need to find 2 things. I want to find my surface area. I want to find my volume. So surface area formula, pretty straightforward, is 4 circles, 4 pi r squared. So I know my radius. Radius is 15. So 4 times pi times 15 squared, or 4 times pi times 225. 15 squared is 225. I do want to leave this in terms of pi. So to do that, we're going to multiply the 4 and the 225. That's going to give me 900 pi. And I'm almost done. I do know my radius is 15 inches, so I can include units. My surface area is going to be 900 pi inches squared. And there's my surface area. For volume is a little bit more complicated of a formula, but it's 4/3 pi r cubed. All I need to know is my radius. That's the only variable. Don't need to find the area of a base, don't need to find the height, don't need to find anything like that. I know my radius, so I'm just going to plug that in. So this is 4/3 pi times 15 cubed. And I'm going to give you the numbers now at the end. I'm going to try and make it so it works so I can show you how to use it on your calculator. But if we were to cube 15, we should get 3,375. That's what 15 cubed is. It's 15 times 15 times 15. So you can always do that. Later I'm going to show you the faster way on your calculator. But that's what 15 cubed is. I need to multiply that by 4/3. I can do that a couple different ways. I can use the natural fraction, the natural fraction that we talked about a little bit before spring break where you hit alpha y equals, and you can get it actually to type in as 4/3. We did this a little bit with the probability. Or you can multiply by 4 and divide by 3. That works as well. But if I do that, multiply 4/3 times 3,375, because remember we're leaving this in terms of pi, you get 4,500 pi. And then again, I need to include my units. This is volume now, so my units are inches cubed. Okay, so if you know your radius, finding the surface area or the volume, it's just a little plug and check, pretty straightforward. A little bit of issue with the cubing, but I'm going to show you on your calculator how to do that in just a little bit. To find the radius of a sphere in example 2, to work backwards, if I know my volume, is a little trickier. But again, you're going to still use the volume formula. We're going to start by writing volume is equal to 4/3 pi r cubed. But this time, instead of knowing what my radius is, I know what the volume is. So I'm going to fill in the volume, the left side of my equation, with that 600. 600 equals 4/3 pi r cubed. And what I want to do is I want to solve for my radius. Now I've just created an algebra equation. Wonderful, we can solve those. There's only the one variable r. Remember, pi is a number. Okay, and we are going to round our final answer to the nearest tenth. So we're going to get a decimal in the middle. We're going to deal with that. We're actually going to multiply through with pi, or divide through with pi in this case. But before we do that, I want to get rid of my 4/3. 4/3 is being multiplied by the pi and the r cubed. So to undo multiplication, we do division. Now, I'm dividing by a fraction. Dividing by a fraction isn't always super fun. Remember, if you're dividing by a fraction, if you've got something divided by, say, like a over b, that is the same as that something times b over a. It's that copy dot flop. So that's what we're going to actually end up doing. And so to save myself a little bit of confusion, I'm going to start by just doing the copy dot flop right away. Okay, so to divide by 4/3 is the same as to multiply by 3/4. So by doing that, on the right-hand side, 4/3 and the 3/4, those cancel with each other. That's the whole point of this, is to cancel with those. On the left, I get 450. Now is equal to pi r cubed. Goal is to get my radius alone. To do that, I have to get my radius cubed alone. So we are going to divide both sides by pi. Now, pi is not a fraction, so I don't need to do any copy dot flops with that. And on the left, they're going to cancel, but there's nothing to cancel on the right. So this is where, okay, we know we're going to round our final answer. This is where I'm going to round in the middle. I'm going to do this. I'm going to get my radius cubed is equal to 450 divided by pi. And I do that, and I get 143.2394488, and I know that that number is going to keep going. That's all my calculator gives me, but it goes much further than that. Remember, we want to round our final answer to the nearest tenth, not the numbers in the middle of the problem. I want to keep that long decimal as much as I can. Now, in a little bit, I'm going to show you on the calculator how to do this, but we need to get rid of this cube right here. We're pretty good about, okay, if I've got c squared equals something, how do I get rid of that? Or if I've got r squared equals something, how do I get rid of that? We're pretty good at saying, oh, well, you square root it. You square root, and you're good. To get rid of a cube, you do something pretty similar. Instead of square rooting, we're going to cube root it. The symbol is very similar. You still have that radical, but now what we do is we put a little 3 in the little corner there to say, I don't want to square root it. No, I want the cube root. I want to know what number do I need to cube to get 143.2394488, blah, 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 blah. Okay, so a little bit, I'm going to show you how to do that in your calculator, but the left, the cube root and the cube, they cancel, so I'm left with my radius. If I cube root the 143.2394488, I get 5.2 3, 2, 2, 3, 8, 6, 8, blah, blah, blah. But now I'm in my final answer, so now I want to round to the nearest tenth. So my radius is 5.2, and I'm almost there. If I'm told my volume is centimeters cubed, that means my radius needs to be centimeters. So my radius is centimeters. Okay, so now I'm going to try and show you on the calculator how to do this. Hopefully it'll still keep recording and it won't kick me out. What I'm going to do is I'm going to go to the camera. Here we go. Okay, so the first thing I want to show you is I want to show you that how to cube something. And there are two different ways that we can cube. One is going to be a little bit more focused on the graphing calculator students, so the students that have those graphing calculators. But either one, we're going to start by typing in the number we want. So we cubed 15 in example 1, so we're going to cube 15 right now. And if I do that on the left, you see I've got that math button. We use it for math frac a lot. Underneath frac, we have decimal, and the number 3 has a little 3. So I can either arrow down there or I can choose the number 3. If I do that, that is going to put that exponent of the 3 right there for us. So that's just like hitting this as the square button, but instead it's a cube button. So it's a little bit more work to get to, but it's fine. We get that 3375. Now, the way that's going to work for anybody, no matter what calculator you have, everyone's going to have a button that looks like this one right down here, this caret button. So it looks like a little up arrow. That tells your calculator you want to do an exponent. So if I want to do 15 cubed or 15 to the 5th or 15 to the 100th power, which actually probably it's going to overpower your calculator, won't be able to do that. Oops, that's a little harder to see now. I'm going to type in 15 and then I'm going to hit that caret button. And if you notice, it now made it so it's got a little exponent box. Now on a lot of calculators, it will just have the little caret symbol there. So that's okay there. But I can do cubed, I could do to the 5th, to the 7th, to whatever power I want, and I get that 3375 back. Okay. To do a cube root, this is a little trickier. I'm going to need to do the math key because on my graphing calculator, it's the only place I can find it. I'm going to show you, if you don't have a graphing calculator, what you want to look for. But if I look at that math key again, okay, so we did this, and I'm going to, there we go. I start off with fraction, and then I've got decimal, and then I've got the cube, and then the fourth option down, it's a little square root symbol with the 3 out in front of it. It's that cube root symbol. If you don't have a graphing calculator, if you don't have the math button, that's the symbol. This symbol right here is what you want to look for on your calculator. You want to look for the button that has it. Now, if you can't find it, if you're still struggling, come to the office hours, the Google Hangouts, and I can walk you through it on your own calculator where to find it. But that's your cube root button. That's what you want to type in. So I can type in whatever number I want. If I want that, 143 point blah, 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 I can get that. I can utilize my answer key. I'm just going to use this number right here because it's right there and I know what the answer should be, but the cube root of that is my 15. Okay, so math is going to be really helpful for a lot of us. Cube roots, caret button for any sort of exponent you want. And then if you have some other calculator, that symbol, that cube root symbol, is the button that you are looking for. Oh, good. I think that worked. Didn't always work for me before. So surface area for volume and spheres, we have our formulas. You have your semi-spheres. Those will pop up most likely in a composite figure of some sort, where you have a sphere on top of like a cylinder or a sphere on top of something else.